Good evening, welcome to my laboratory. What you're looking at there, that little black thing that looks like a transistor right there, is an Allegro Microsystems A3503 Ratiometric Hall effect sensor. This is actually an obsolete part, so they're available really cheap on the Chinese market. I paid, well, altogether including shipping, about 40 cents a piece for 10 of these delivered to my door from China. I got 10 for $3.98, and that's shipping included. And it's a ratiometric Hall effect sensor, so it runs on 5 volts in, and then it puts out a signal that's, or a voltage rather, that's proportional to the sensed field from a magnet. It can be used for all kinds of things, and what I've got here is I just have it rigged up to act as a magnetic field sensor operating a little switching circuit, which is right there, that I put together just a few minutes ago. I'll show the schematic very clearly in a moment, but we have the Hall sensor input coming in through this jack here, and I've got a voltmeter monitoring the output of the Hall sensor. This is a 78L05 voltage regulator to provide a stable 5-volt supply to the Hall sensor, and also to provide a reference voltage for the op-amp. This is a TL082 dual JFET-input op-amp, and I'm using both of the op-amps in there to separately control the 2 indicator LEDs there. Okay, and then here are the 2 potentiometers that individually set the set points. The op-amps are configured as comparators. So what they do is, as the voltage from the Hall sensor goes up or down, you're able to set a set point with the potentiometers, so that when the voltage is above a certain level, one of the LEDs turns on, and when the voltage is below a certain level, the other LED turns on. I did this with the separate op-amps so that the set points could be individually set. They're independent of each other. And the way this works is the Hall sensor's output goes to the inverting input of one amplifier and to the non-inverting input of the other amplifier. The other inputs are of course set by the 50K potentiometers with reference to the 5-volt output of the TL082, or rather of the 78L05 voltage regulator there. So I'm giving the unit about 7 volts now of input. The voltage regulator drops that down to a stable 5 volts for the Hall sensor and the reference voltage, but the raw input is being switched by the op-amp to go out to the LEDs or to some other load, like a switching transistor to drive a heavy load if you wanted to use this for a pulse motor or something like that. Okay, so let's see if I can get everything in there. So you can see the voltage that's coming out of the Hall sensor right there, and since there's no magnets in the vicinity, the output voltage is just about halfway in between the positive supply and the negative supply or rather the positive voltage, which is 5 volts, and the negative 0 volt level, so about 2.48 volts there. That error is probably actually in my multimeter rather than in the Hall sensor. Okay, now here's a little magnet. This is just a little ferrite magnet. So as I approach the Hall sensor, you can see that the green light flips on, and you can see that as I get closer and closer and closer, the voltage goes up and up and up and up and up and up and up until we're somewhat over 4 volts. And if I flip the magnet over, see the red light come on, and you can see the voltage output of the Hall sensor going down, 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 down. Right? And this thing is very sensitive. I'm about 2 inches away from the Hall sensor with the magnet, and I think you can see that the change in voltage required to flip the state is about 20 millivolts, and that could be made even less by careful adjustments of the potentiometers. Or you could set different voltage levels. You could set so that one comes on when you're really close and the other one comes on when you're further away, because of the independent use of the op amps. And of course, with a stronger magnet, it'll work further away. All right, that's it. Thank you for watching.